Alright, hey guys, thanks for coming out. Welcome to Kansan. Welcome to our meetup. I think there's people in the kitchen, so it'll be cool if they join us. But oh, there's someone? Okay, cool. So welcome to the meetup. I'm David Zuluaga. I'm a developer here in Kansan, and today's meetup is really cool. It's about Angular. Isn't it? Blockchain. So let me introduce you to our presenters today. Justin Tomlinson, he's Kansan, he's director. And Sean Michael, he works for Salt, and he's a blockchain expert. That was another joke.
I'm not quite an expert, but I'll try.
Cool, so I'm gonna hand it off to Justin, and he's gonna talk a little bit about Kansan and take it from there.
Yeah. So welcome everybody, and thank you for joining us. And yeah, I would like to talk just a little bit about Kinzon before we get into it. This is Kinzon, where we are right now. Kinzon is a software consulting firm. We do all kinds of stuff. We do architecture, front-end, back-end development, business analysis, dev test, a lot of different services that we provide. We mostly, in the past, have been mostly focused on like the media industry, and so a lot of like television, cable companies, that kind of thing. We're kind of branching out into big data, cloud development in general. But most importantly, we are hiring. We are hiring for so many different positions. We are hiring for back-end, front-end, architects, platform, even an office coordinator. So because sadly our wonderful office coordinator is leaving us soon. But so if you are at all interested, please come up and talk to me or talk to any of the other Kinzon people, and we can get you hooked up because we are really looking for good software people to join our team. This is our biggest office. We have another large office in Providence. It's about this size, Providence, Rhode Island, and then we also have smaller offices in New York and LA, as well as a growing presence, I would say, in London. Mexico, yes, Guadalajara, Mexico, actually. So, and we are also a subsidiary of a company called Amdocs, which is founded in Tel Aviv, but they have offices all over the place. And personally, I think we're a pretty cool place to work. So, I'd love to talk to anybody who wants to about working at Kinzon.
Cool. So I guess I'll give my pitch for Salt Lending. I am Sean Michael. I'm a former employee of Kinzon, and I am now working at Salt Lending as a software developer. How many of you, I think I'm stealing Justin's intro right now, but how many of you own cryptocurrency in this room? Quite a few of you. How many of you own Bitcoin, if you don't mind me asking? How many of you own Ethereum? Bitcoin Cash? Oh, that's too bad. No, I'm just kidding. So Salt Lending is a blockchain-backed loan service. So basically, you can take your cryptocurrency today, and you can come to us, deposit your cryptocurrency as collateral in an automated system, and we will give you cash for that cryptocurrency. I believe we're the only loan system for blockchain-based assets right now that gives fiat. I know there are a few other companies that are popping up here and there, but we're actively doing that. We've given out, I think, about $27 million in loans so far, and we have a demand of about $1.3 billion. So we're trying to grow fast. We also need developers, so not to steal Justin's thunder again. If you are front-end, back-end developer, I know we have a bunch of other positions open. I just know more about the engineering side of things. Please come up, chat with me afterwards, or if you just want to talk cryptocurrency, I'm always open to that as well. So you want to get started?
Sure. Yeah. And so on the slide we had previously, there are some. If you want to, we're going to have we're going to go through some slides, and then we're going to have a hands-on code section. And so here are some links to the prerequisites for setting up on your machine. It's fairly straightforward stuff. Unfortunately, we don't think we found a solution for Windows, so hopefully that's okay. Yeah, unless there are definitely Docker containers you can pull if you've got Docker set up. But yep, and then Wi-Fi information in case anybody needs it. Kinzon guest password is welcome to Kinzon.
Yeah, and don't feel rushed. We'll give you like 5 to 10 minutes in between the talking portion and the coding portion. So if you need to install all this stuff, you can do it during that time too.
right, so tonight we're going to be talking about creating blockchain basics with Hyperledger. And so our agenda, what we're going to cover, most of the talk I think is going to be about blockchain basics, and we're going to talk about number of different things that are necessary to make blockchain work. Then we'll have some information on Bitcoin and Ethereum, and then when to use blockchain, what the use cases are, how you can kind of decide is this a good project for blockchain or not. We're going to dig into a little more detail about Hyperledger itself, and then we are going to take a short break and then do some code. Yeah, about Kinzon, I already kind of talked about this, but yeah, we're a cool company, come work for us. So we did ask about cryptocurrency, and as you know, cryptocurrency is definitely the most talked about application of blockchain, and for good reason, because it really is a pretty revolutionary thing, and it really does show off what blockchain can do very well. But we wanted to go a little beyond that and show more about the technology behind it and potentially some other applications that aren't just a cryptocurrency. So like I mentioned, we are going to talk a little about where the cryptocurrencies fit into this, but that's not really the focus of our talk. We're actually going to be looking at the technology beneath them, and so what we're looking at could be used potentially to build some kind of cryptocurrency or something like that, but we've actually got a different application in mind when we get to the coding part. So what is a blockchain? Can kind of distill it down to a few points. A blockchain is a distributed ledger, and we've got more slides on these points coming up. It's forged by consensus algorithms, and then it has a system for smart contracts of some kind. Blockchain really was kind of a confluence of a whole bunch of emerging technologies that just came up that are necessary to make this work. Cryptography is a big piece. Transaction timestamping is very important. Peer-to-peer networks is central to it. Shared computation and consensus algorithms, which we'll talk about in a little more detail, are all necessary to make it work. So what's a distributed ledger? A distributed ledger, if you think of an accounting ledger where people mark down on their books, I got this money in, this money went out, this person gave me a frog, I gave this person a talking to, or whatever they write down. That's usually just all stored in one central book, and then the owner of that book has all of the information and holds it all there. A distributed ledger is essentially taking that same idea, but making it so that there are many different devices, often in different locations, different regions, that are all connecting together to join into this ledger, and they all share in it. They connect usually using a dedicated application, such as your wallet. In the case of your Bitcoin, that's the application that connects you to the ledger. And then participants can record transactions in the ledger, such as, for instance, I transferred Bitcoin, half a Bitcoin from this person to this person. That would be an entry that gets recorded into the ledger. Consensus is a pretty actually deep topic that we're not going to get too far into tonight, I don't think, but there are a number of different algorithms that are used to establish consensus, and it's really critical because the consensus algorithm is what allows the different participants in the node to all agree on what's in the ledger. So because you don't have just one book with all of the entries in it, you have to make sure that everyone out there has the same information and the same entries in the ledger, and that they all agree on what's there. And so the consensus algorithms, and there are many different ones, there's proof of work, proof of stake, simplified Byzantine fault tolerance, a lot of fun algorithms there are used to make that happen. And then what it also does is it prevents malicious actors from coming in and messing with that data, deleting it or changing it, because we've ensured using this algorithm that everyone has the same information in each of their copies of the ledger. And finally, cryptography. Cryptography is, of course, a huge mathematically intense topic of its own, so we're not going to get too deep into it tonight, but a couple things just to call out and a couple concepts because they're important to blockchain in particular. Hashing is something probably most of us know what that is. If you're a Java developer, you've seen the hash code method and all of that, but hashing essentially takes some sort of input data and compacts it into a string that's at least close enough to unique in that if you put two different input datas in, you're highly unlikely to get two different hashes out. Another important piece of hashing technology is algorithms is that they can't be reversed. And so if you have a hash, there's no formula that's going to let you take that hash and turn it back into its original input. But if you change that input even slightly, you will get a wildly different hash. And so the hash is kind of a way of almost tagging the contents and just putting a label on it that's consistent, that anybody who hashes the data gets that same hash back out. that can be used, and we'll see in just a second, is very heavily used in blockchain and is really key to the technology. Also, the public and private key signing, again, I imagine most people are familiar with this, but essentially it's asymmetric encryption where I can take a public key and, well, in this case, we're actually mostly concerned with the signature, in that if I have a private key, I can sign a transaction, put a signature on it that goes out as an additional piece of data. Anyone with the public key can verify and can run an algorithm to say, hey, did that really come from the right private key? And they can verify that it really did, but they can't generate one themselves. Only with the private key can you generate this signature. And it's a bunch of mathematical magic that makes that work, that, to be honest, I only halfway understand, so I'm not even going to pretend to, but it really does work. And it's the same as the asymmetric encryption, where you can take a kind of in a reverse thing, you can take the public key, encrypt something, and only the person with the private key can decrypt it.
Yeah, and I know I saw a whole bunch of hands go up when we were talking about owning cryptocurrency. But if you're in the group that does not own cryptocurrency, your public key is basically the address that people can send a cryptocurrency to. So say Justin wants to send me 15 Bitcoin. That would be very nice. He could always sign a transaction with his private key, and that transaction, he could say, send this to this specific public key. And that public key would then be the owner of that 15 Bitcoin, and that would go onto the blockchain. So that's how it's used in cryptocurrency. We'll see how it's kind of used in other different types of blockchains as we go along. So smart contracts. I feel like smart contracts are most talked about when people start going into Ethereum. Ethereum, I think quite a few of you own that. Is everybody familiar with Ethereum, or some people maybe not so much? Yeah? No? Ethereum in a lot of ways is like Bitcoin. It's a cryptocurrency, but on top of being a cryptocurrency, they have a virtual machine that allows for smart contracts. Smart contracts are basically software programs that execute on the blockchain. So I could say, Justin and I want to engage in some sort of sale. He wants to sell me his house. So Justin has the deed to his house. He wants like 50 Bitcoin for his house. And so we could set up a contract that says when both people send their assets to this contract, we will then release those assets to each person. So if his house was on a blockchain and he had a token asset to represent that house, he could send that token to the contract. I could send the Ethereum to the contract, and then we could transact in that way. The contract actually has some programming in it that would make that transaction happen. It allows a lot more stuff to happen on the blockchain. So you're not just sending cryptocurrency or money back and forth. You can do all sorts of programmatic stuff on the blockchain. Financial contracts, just you could imagine what you could do with programming. It can
make
go ahead.
Question.
Yeah.
Does it make like the smart contract someone has to program, right?
Yeah.
So in that case, transactions are there's still a third party involved in transactions, which is the person who write the smart contract. Is that accurate to think, or?
In a way, they're involved in the process, but if you're using not a permissioned blockchain like we're going to talk about today, if you're using a public blockchain like Ethereum, anybody can see that contract once it's deployed to the Ethereum blockchain, for example. So if someone creates that contract, they deploy it to the blockchain, they're no longer part of the picture, really. That just exists on the blockchain. And Justin and I could look at that contract and say, yeah, that does exactly what we want it to do. We can trust this contract. We don't have to trust you as a third party unless we didn't really understand what that contract was doing.
Yeah, but someone has to make the contract.
Yeah.
Well, kind of like, you could go to a store and buy a book of pre-written contracts, and then I could take one of, like, a contract for marriage or for selling your house or whatever, and I could just take it and cut it out of the book and pull it out and say, here, sign this contract to buy my house.
Yeah.
Someone out there wrote that contract, but they're not really involved in the exchange between us, if that makes sense.
Exactly.
It's the notary, right, that would be your stamps in with blockchain.
Right.
Blockchain would be
The
your
blockchain
notary.
is your notary, yeah, in that situation, exactly. So it kind of takes over that third party, the place of that third party, the notary. It can be written in many different programming languages depending on what blockchain framework you're using. Ethereum uses Solidity. I'm probably going to use that as an example a lot during this talk because it's what I know best. There's other giant blockchains coming out, cryptocurrencies coming out that are using different programming languages under the hood. I know that Cardano is one of them. They're using a Haskell-like programming language for their contracts. There's a whole bunch. So let's move on to the next slide. So that brings us to permission versus permissionless. When we're talking about these cryptocurrencies like Ethereum, Bitcoin, those are what you would call permissionless blockchains. Anyone can join them. They basically commoditize trust because everything that you do, every single contract that takes place gets put on that blockchain and everybody can see it. So you also, you can, yeah, it says Bitcoin and Ethereum are permissionless there. For permission blockchains, you have to be pre-verified to get in. And permission blockchains include all of the Hyperledger projects that we're going to talk about today. So for a lot of people, permissioned might not be as cool to think about as this egalitarian, democratic blockchain that anyone in the world can actually run on their computers and use at any point in time. That's censorship resistant. That is permissionless. Permissioned, you're going to have a blockchain that exists amongst particular participants. And those participants are going to be chosen amongst the consortium of people that are involved in that blockchain. It's going to be used more often for enterprise type software where you have multiple constituents that maybe aren't the same company or organization that work together in the same chain, maybe a supply chain, maybe some sort of government verification. Those are the types of use cases that you'll see for permissioned blockchains. And you can see at the bottom it says good for supply chains. A lot of times you have supply chains where you have multiple entities that are involved in passing a good from its origin all the way to the person who ends up buying that good in the end. And each of those entities is going to run its own ERP system, keep track of that good. When that good gets to the vendor, how does the vendor know that it's authentic? They don't have the information from the ERPs from every single system beneath them in the supply chain. So they can't really know that. And that's when permission blockchains would come in handy. You have multiple constituents that work together in some sort of supply chain or life cycle of a good, and you want to be able to verify certain aspects of that product. So I'm going to dive a little deep here, but I think it's good to kind of understand the Bitcoin blockchain as a basis for understanding a lot of these other blockchains that are out there. Bitcoin, as far as we know, was the first development of an actual blockchain in existence, and it pulled together a whole bunch of these technologies. So at its base is a lot of the same technologies that you'll see in other cryptocurrencies and other permission blockchains. So other permissionless blockchains and other permission blockchains. So basically, the goal of the blockchain is to make sure, or it basically confirms the integrity of all of the data that has actually occurred. So in a lot of ways, it is creating some sort of concrete ledger of every single transaction that has ever occurred. And it has to be tamper-proof, because otherwise, if this is not tamper-proof, someone could go in and say, oh, let me change this transaction where someone sent me 10 Bitcoin and make it 50 Bitcoin and make sure I get get more money out of this transaction. And so I'm going to dive into how Bitcoin makes that actually happen, how it becomes high integrity, and also make sure that no one can tamper with it. So as Justin said, hashing is a simple mathematical process that takes an input of any size and produces an output of a fixed size. You can think of this as like, any sort of computer data in ones and zeros goes into a hashing algorithm, and it will output maybe like a 32 character string out of that. If the data going in changes in any way, that 32 character string will always change. And that's why hashing is powerful, because you can always tell if something changed in the data that's getting passed in. Bitcoin, it uses a hashing algorithm in order to hash new blocks into the blockchain. And each of these blocks up here contains a certain amount of transactions. And so in its consensus algorithm, people will run nodes, and every single person running a node will have the same exact ledger on their node of all of the transactions that ever occurred on the blockchain of Bitcoin. And we have to make sure that no one ever changes that ledger and tries to do something malicious with that in any of the nodes that are running. In order to do that, the blocks are set up in a way where the previous block, I don't know if I can highlight up here. Sorry. So the hash of this block gets passed into the next block. And that hash is used to create the hash of this block as well. And that gets passed into the next block. So if any of the transactions are changed by a node that's malicious, then the actual hash of this block and the next block will be incorrect. And all of the other nodes will see that and say, hey, this is a malicious actor in our network. This person is doing something malicious. Do not accept the block that they're trying to enter into the blockchain. So that's basically how consensus works in Bitcoin. And they use something called Merkle trees. And a Merkle tree, if you're familiar with Git, does the same exact thing. So any change that you make to a transaction will cause the root hash of the block to change. And all of the root hash gets calculated into the hash of the block. And so if anybody ever tried to tamper with transactions that already occurred and tried to make them out in their favor, the other nodes would recognize that and shoot down the blocks that they're trying to add to the blockchain. So we've been talking about Bitcoin and Ethereum. They're two major players in the blockchain space. Bitcoin was created by Satoshi Nakamoto in 2009. If you haven't read about that situation, it's really interesting. No one really knows who he is, or if it's a he or she or a multitude of people that actually created Bitcoin. They haven't come forward, so there's no actual figurehead, the creator of Bitcoin, who people can recognize. They mined a Genesis block, that's the first block in the blockchain, instead of doing some sort of pre-sale to start their blockchain. They use a proof of work consensus, which means that you use computing power to solve cryptographic equations in order to mine a block into the blockchain. And it's used as a digital currency. The algorithm that they use for that hashing is the SHA-256 algorithm. They have 10-minute block intervals, and because it's a public blockchain, they should have no downtime, should be transparent, censorship resistant, and tamper resistant. I know that there's a company that actually deployed satellites into space that propagate the Bitcoin network. So if our internet ever goes down on planet Earth around the world, the Bitcoin network will still be running. So it's pretty secure.
So don't invest in Ethereum.
Ethereum?
Yeah.
No, I don't give investment advice. So. No, Ethereum's awesome too. It's what got me really into cryptocurrency as a developer. It was created by Vitalik Buterin in 2015. They had a pre-sale for the release. I think they did it on their own on the actual Ethereum blockchain, just to test out their own product, basically an ICO. How many of you have heard of ICOs? Their initial coin offerings, basically people are able to raise money and they give you tokens in exchange. Whether those tokens are valuable or not is dependent on the cryptocurrency you are buying. But Ethereum has enabled a lot of that sort of use case. It uses a proof of work consensus, and they're planning on moving to proof of stake consensus, which is different from what I was describing with computing power solving algorithms. Instead, what you have to do is you have to own a large amount of that cryptocurrency, and you have to run a node and stake that currency on the node. And it basically says my node will put transactions into the blockchain. If my node ever acts in a malicious way and the other nodes realize it, I can lose all of the money that I staked into the blockchain. So it disincentivizes people from basically doing malicious acts on the blockchain. It's got 12 to 14 second block intervals. Also no downtime, transparent, censorship resistant, and tamper resistant. And these are permissionless public blockchains. So we're going to talk a lot more about the permission side in a second, but I just wanted to get this out here because it's kind of what has brought blockchain technology into the purview of many people, and a lot of big companies are trying to get into that space, and they might not know why, but it seems like for enterprise software, permission blockchains is actually a legit use case. So we'll get into that in a second. This is probably really hard to see for everybody. Sorry. I don't know if I can zoom on this. It's not going to let me zoom. But I thought this was a neat diagram. It shows you a bunch of different use cases up here for how you can use a blockchain. You could do transparency within real estate agreements. You could do insurance for flights, wills and inheritance. You could put on the blockchain as contracts. You could put automotive insurance. There's a whole bunch of use cases out there. Not every one of them is going to be perfect for the blockchain. There's probably some on here that you could point out and say, hey, I could do that with a centralized database. I don't need a blockchain to actually do that. But I mean, there are definite use cases out there, in my opinion, for blockchain technology. You want to jump in?
Oh, on the decision path? Sure.
Yeah.
Yeah, and so this is just an example of if you're considering a particular use case, some questions to ask about. First of all, is blockchain a good idea for this particular use case, as well as would you go with a public or permission blockchain? And so I won't read through all the questions there, but essentially, you know, for instance, if we don't have multiple parties involved, number two, then why do we need a blockchain? We can just use our own private database if there's only one of us. If the rules governing the participants aren't uniform, then probably blockchain is not going to be the right thing, because the whole point is you have to encode your contracts as actual software code, so you have to have uniform rules. If you don't need an objective immutable log, then heck, you probably don't need a computer. And then at the end, you know, are the transactions public or not is pretty much your deciding factor. Do you want this to be something that everyone can see what's going on and everyone can join in this egalitarian golden age of mankind, or do you want it to be your private little club that you shut people out of? And so yeah, I'm going to move it. Let's move on and talk a little about Hyperledger. Hyperledger is kind of an interesting project in the Linux Foundation. It's not so much a type of blockchain or a particular framework or a particular library, but it's actually a whole collection of them. So you could think of it as analogous to like Apache Software Foundation, you know, where Apache has a lot of different different open source tools for a lot of different needs, some of which even kind of fill the same need and are alternate ways of doing that. Hyperledger is very similar to that. And we will in fact talk about these in a little more detail, but they have, you can see here on this slide, there are frameworks. These frameworks are all like really different ways of making a blockchain. So you could make a Fabric blockchain, or you could make a Sawtooth or an Aroha, and they all have, they're all different. They have different consensus algorithms, different rules, even in terms of whether they're permissioned or permissionless. They can be different in that regard. And so you wouldn't plug those into each other. They also have modules, and the modules are like tools or extensions or something else that you can plug often into just one specific framework, and then they may go port it to other frameworks as well. But so Hyperledger, unlike Ethereum or Bitcoin, which are like one specific kind of blockchain with rules, with a specific set of rules for that blockchain, Hyperledger actually encompasses quite a few. And they're doing that on purpose because they want to really give people options to pick what's right for them. So yeah, and just a quick rundown of the main Hyperledger projects that are out there right now. Not all of these are finished and ready for prime time. In fact, I'd say most of them probably aren't. Most of them are not yet to the 1.0 state. Additionally, they seem to be very interested in adding a lot of new projects in the future. But for now, these are the main ones. Fabric is what we're going to be looking at tonight. Fabric was their first project, right? Their first Hyperledger project was Fabric?
As far as I know, yeah.
Yeah. And so it's probably the most mature and most developed. It is an entire modular plug-and-play blockchain system with quite a few different features that you can put in there depending on what you like. It only does permission to blockchains. It does allow for, because of that, it does allow for confidential transactions, and it's actually written in Go or Golang. Sawtooth is a newer one that I think just recently hit the 1.0 release. It can do either permissioned or permissionless. It has some certain, its consensus algorithm is a little, is less computationally intensive, requires less computing speed because it actually takes advantage of some new security feature in Intel processors that I'm not going to say too much about because I don't know too much about it, but it takes advantage of some security feature in the new Intel processors that allows you to run like code in a special safe space. And Sawtooth does that to allow you to get the consensus algorithm with less intense computation, and it's written in Python. Aroha is another framework that's specifically targeted towards mobile application development. It's in C++ and has libraries for Android and iOS. Indy is kind of a specialized one it's trying to address a need for identity management. And so they've thought a lot about things like disclosure and how if you've got information associated with your identity and you want to decide which company should have access to that, that's the kind of things that you can set up with Indy. They have some neat ideas for company, just keeps a key to your data but doesn't keep the data itself, and so the company still has ways to find out what they need, but they're not holding all of your private data like often happens with identity management today. I don't think Indy is at a 1.0 yet. And then Burrow is kind of a specialized engine that was specifically trying to bridge the gap with Ethereum. And so it uses the Solidity language and the Ethereum virtual machine spec that it has a smart contract engine that implements that. And so it's kind of bridging the gap. And from what I've seen, they're actually trying to get that worked in with some of the other frameworks so that you could use that same engine with Fabric or Sawtooth or the others, but right now Burrow is kind of its own separate framework. And then for modules, we've got a couple key tools. Hyperledger Composer is really cool, and we are going to be playing with that tonight. It's got a few different tools. It's the one in particular that we're going to be looking at is the Composer Playground, which is kind of like a web-based IDE for blockchain, IDE/bootstrapping thing that will build a whole bunch of stuff for you out of just some fairly simple inputs. They also have a REST API support, which is a loopback connector, as well as this BNA Business Network Archive tool that kind of is like your jar packager and deployment tool in Java. Explorer is another pretty cool tool that allows you to just view and visualize a blockchain and see the data in there and move around and explore it. And then Cello is it's really more infrastructure support. It's specifically designed to support the idea of blockchain as a service, and it has tools for like viewing and maintaining the nodes in your network and the network itself, and kind of the more platformy infrastructure kind of stuff.
Cool. So We're going to take a quick break in a second, but before we get started on actually programming and building something with Hyperledger, I just kind of wanted to show you what the Fabric blockchain actually does behind the scenes, just so you guys have an understanding before we jump into code. In this diagram, you can see there's various users of our application built on Fabric. So we have a fisherman, a regulator, and a restaurant. And you can imagine that all three of those are involved in a supply chain where fish go from the fisherman all the way to the plate at the restaurant. When a user actually, so say one of those users wants to make a transaction and say, hey, I passed the fish off to this person, they would need to go through that Node.js application. We would probably have some sort of UI in front of that. When that request goes out, it is considered a proposal, and that proposal goes out to one of those smart contract functions there. So we could be sending out something for record the catch of a tuna. So we're hitting that record tuna smart contract address with our proposal. That actually writes some pseudocode, sends it back to the Node.js application, and then that gets sent out to the ledger. Then the ledger will run through that code, make sure it's correct, and also make sure that nothing malicious is happening, and then it will confirm that code to the actual blockchain. And that transaction could kick off an event that updates something in the UI for one of those three people involved in the application. And we're not going to do an application with fish, but we're going to build an application for coffee farmers in Latin America that need to send their coffee to the US. And we want to ensure that that coffee is single origin, make sure it's maybe organic or something like that. So,
Shade grown.
yeah, shade grown.
Coffee.
So up here is the problem we're going to solve. We're going to build a supply chain solution for Latin America coffee farmers and U.S. vendors that guarantee single origin and fresh product without a third-party intermediary. And we're going to do that with a Fabric blockchain using Hyperledger Composer. So if you haven't installed it and you guys want to code along, please go to the link in the setup. If you're having any issues, let us know. We can try to help out. I also have a front end for the application that I didn't want to build out as part of this demo because it would take up too much time. So if you want to clone that down, we can run that locally and see our interactions with the blockchain itself. We're going to take like a 5 to 10 minute break. You guys can grab some more pizza, grab some beer, and then we'll start coding after that.
Yeah, let's come back at 7:15.
Man, can I turn that off?
We should be back. Let's see. Make sure we've got audio out to the wide world. Hello? No? He says no.
I say yay.
What's that?
I say yay. I'm saying no. If we could only form an algorithm to decide our consensus.
Right. Sweet. I think we have consensus. We have audio. All right. Awesome.
All right. So I know probably not all of you are going to code this, but some of you will. So I'll try to stay on task here as we go through building a blockchain with Hyperledger here. We're going to be using Hyperledger Composer, which Justin explained a little bit earlier. Hyperledger Composer is really awesome because it allows you to stand up a Hyperledger Fabric blockchain and an API that interacts with that blockchain, that Node SDK that we were showing you on the previous slide, fairly easily. The downsides of it is it hides a lot of the magic under the hood. So I'd imagine as you start building out a production grade enterprise blockchain solution, you might run into situations where this would be limiting. I honestly have not actually built a enterprise grade production blockchain with Hyperledger. This is just something I was interested in and wanted to do some discovery work for this presentation. So I'll do the best that I can leading you guys through this. If you have any questions, just feel free to speak out. Has everybody started Fabric already? No. So maybe we should start back at the website that we had up in the beginning. So how far along are you if you have not started your Fabric?
I got through all this.
Okay, so you downloaded it and you should have ran this start Fabric shell scripts. Okay, so if you have not gotten to this part right now, cd into your Fabric tools, and you're going to want to run the start Fabric shell script. And this is part of a lot of the magic that they give you with Hyperledger Composer. They also have setup scripts for you that start up, I think, 3 or 4 Docker containers for you that run the entire network. So I just tore down Fabric, so I'm going to run the Fabric tools startup shell script right now. And you should see something like this, basically telling you what it's doing with Docker Compose. So you can see here it's creating CouchDB. It's creating a peer, and your peers are the nodes in this blockchain that confirm the transactions. It also sets up a certificate authority, and on these blockchains you'll want to give authority to specific members. So in the example of the coffee farmer, we're going to have a vendor and we're going to have like a co-op that both run nodes on this network, and each of those would get a certificate, and when they want to put a transaction onto the blockchain, they'll have to sign that transaction with a certificate, and the nodes will confirm that those transactions came from a valid certificate from the certificate authority. I was speaking with someone during the break about ways to incorporate these certificates into consortiums. And a consortium is just multiple constituents in the blockchain. So for example, there's a company using this technology right now in the diamond industry, and they have multiple portions of the blockchain where the diamond, or sorry, of the supply chain where the diamond passes through, and each of those constituents has a certificate, and they're able to confirm that, hey, I got this specific diamond. It is a valid diamond. It is not a blood diamond. And by the time it gets to the actual consumer, the consumer can be assured and they know the integrity of that diamond and where it came from. And so in that situation, you would give a certificate to each of those members in that supply chain. And if a new member wanted to join, you could set up a certain type of governance over the certificates. So if it's democratic, you could vote people into that consortium to participate. So are you all set up? Fabric start? Cool. So we also need to create this peer admin card. So you'll have to run this shell script. And basically that is giving us admin privileges with our certificate. So there's quite a few steps for setup, but hopefully your computer will work the way it needs to. And we're going to skip this playground part. The playground is a very easy, safe way to introduce people to this technology because it's basically a sandbox UI where you can run transactions and create members on the blockchain and actually edit code for this Fabric blockchain that we're creating directly from your browser of choice. And the reason I'm avoiding it is because I assume that we're mostly developers in here and you're probably going to want to jump into an actual code editor and modify code as you're developing one of these blockchains. So there's two portions to this blockchain. We're going to create a network and we're also going to create a UI. I believe I had that UI up on the slide during the break. Hopefully you guys clone that down because we're going to use it in a little while. Okay, so we've got that pure admin card set up. And we're all going to type in yo because we installed the Yeoman generator. And you should see you might have other things installed with Yeoman. Yeoman basically generates scaffolding for projects. It's used a lot on the front end for JavaScript projects. And you should see Hyperledger Composer in there and click enter. And it will step you through a process of actually generating a project. So the first thing we're going to want to generate is this business network. After we generate the network, we're going to generate an Angular application. You're just going to clone the application that I already have, but technically, if you wanted to build this on your own, you generate that Angular application. So we're going to call this project origin-coffee because we want to make sure that the coffee that gets to the actual consumer is from a single origin. It was from the person, the farmer that produced it, that you say produced it, and we can verify that with the blockchain. Put in anything for description, anything for author name, email, same, license, and then namespace. Let's call it org.origincoffee.biznet. And the reason we're namespacing is because you can deploy multiple blockchains to a fabric. And if you have multiple blockchains, you'd want each of those blockchains namespaced. So that should build a project for you. And I will cd into Origin Coffee, and I will open my editor. Just get started with code. And this is awfully small, so let's bump up the font here a little bit. Okay. So when you jump into this project here, you should see a models folder and a lib folder, and that is where we're going to do all of our work today. Let's see here. Seems like my old code is still up here, so let me get rid of this real quick. Sorry. So yeah, we have our lib and models here. And you should see this weird model file that ends with a CTO suffix, and this is specific to Hyperledger. this is where you're going to build out the models of your blockchain. And by models, there are 3 constituents that consist of a model. And one is participant, one is an asset, and one is a transaction. So in our situation of coffee, what would be a participant in our blockchain? Does anybody have an example of someone we could add as a participant? Grower, yeah, great. So let's put a participant as farmer. And what else? That farmer needs to sell to someone. So, yeah, I'm gonna throw it in as vendor. So I'm sticking to certain semantics right now because I don't know if we change the semantics. I don't think it will mesh well with the front end that I set up that we're gonna run it with. So we'll call them the vendor, and we want it to be identified by something, and we'll say email. And if we had string email here, that's cool. I just felt like, you know, a farmer in a country like Honduras or Guatemala might not have an email, so it might not be the best identifier or ID of that participant in the system. So I would call this some sort of, I would want to just make an ID of some sort, a random ID, just for the sake of the demo. There's one thing though that I noticed is that both of these contain IDs, and there's this idea of abstracts in the modeling language of Fabric. So what I'm going to want to do is create an owner abstract of whoever is owning that coffee. So let's create participant owner, or sorry, it's an abstract. So we label it as abstract. And it's going to be identified. If you have VS Code, or I believe Atom Editor, you can download the IntelliSense for these files. So it's giving me a bunch of hints right now because it knows exactly what I should be typing in. And we'll identify it by a string. Sorry. All of the types are capitalized, like in a lot of typed languages. And we'll call it owner ID. And then all we need to do is extend these participants with that owner. And so we can erase this, and we can say extends owner. And now we are extending this owner participant with an owner ID. So what else can we throw in the farmer? I'm gonna just put some stuff in here. We could say we'll get the farmer's first name, we'll get last name.
Make sure you have the second last name.
Yeah, that would probably be the correct way to do it.
I was gonna say you spelled that the fist name.
Oh, thanks. And we get down to something like country. We want to tell people when they go to buy their coffee, what country did this come from, and what region did that coffee actually come from. So I think that's an important part to add to the farmer. There's also a construct of enum that we can use. So I thought this would be a good place to display an enum. So we can create an enum of country, and all the various options of that enum could be Colombia, because we got a Colombian in the audience. Guatemala. I'll make them capital just for convention. Then we could do Honduras and Brazil. Cool. So we got that set up. I think the vendor should get a business name, just so we know who the vendor is. The ID might not be sufficient there. And then we have our asset, which is just coffee, right? And our coffee is going to be identified by some sort of ID. We'll call it coffee ID. And change this here to coffee ID. let's see, what we would want to know about this. So I just want to show some basic types, if I can jump to it really fast without interrupting this demo too much. Yeah, I'm not sure exactly where it is, but we have access to various types that we can use for modeling. And sorry about that. And one of those types is a double. And I think we want to tell people the amount of pounds that I'm imagining, like burlap sacks that farmers are sending their coffee in. So we want to know the measurement of pounds of that sack of coffee. And we could do a Boolean also and say whether or not it's organic. That would be tested probably at a co-op, whoever is actually exporting that coffee. And then they could stamp that, and they could be the official kind of constituent behind verifying that it's organic. Then we've got date time. Oops. And we could do the time that it was harvested at, because I'm sure our customers want to know that it's fresh by the time it gets to them. When they buy it in the store, they could know exactly when that coffee was harvested. And we could do a string for the variety of coffee that was actually harvested. And then we're going to do something cool right here. We're going to show a relationship. So basically we're pulling in the owner so that we know who the owner of this coffee is at any given point in time on the blockchain. It could be the farmer, it could be the vendor, whoever actually acts as the owner. I think when we first enter in the coffee assets, it would probably be the farmer. And then as a transaction occurs and that gets sold to a vendor, then we would transact and change that to an actual vendor. Yep. And then we have one transaction that occurs, and it's basically the trade of the coffee. And in this trade of the coffee, we actually don't need to supply any sort of explicit types here. We're just going to show the relationships. So you're going to give the coffee in a transaction a new owner, and you are going to say which coffee was actually transacted, which burlap sack was actually transacted.
Sean, do you need to put a name on the country field?
Yes.
In farmer?
Thank you. And I actually left one out here. I wanted to put in region as well. So is everybody kind of caught up?
Make country uppercase. I don't know if that'll matter, but the variable name.
Oh, yeah, it's probably better.
And by definition, reject any value that wasn't in the enum for the country.
Yeah, you would get an error at that point. You're basically locking it down. We didn't have to do that, but I
Makes
just
sense, yeah.
kind of showing the different types that you can use inside of the models here. There's more stuff that you can do with models. I'm just showing the basics right now. You can also watch for events. So you can set up specific events in addition to transactions, and those events using WebSockets can trigger certain actions inside of a UI that you have set up. But right now we're just going to do kind of a static UI. And so all of this is set up for us. What this is going to build is telling Hyperledger that Hyperledger Composer, that we want to build an API that contains RESTful endpoints to add participants, remove participants, add assets, post transactions to the blockchain. Hyperledger Composer is going to set up all of that for us under the hood, which is part of the magic that I was telling you about. We're not quite there yet because we're missing one component in here, and that is how to handle a transaction. So right now we're telling the transaction that we want to pass the new owner into it, and we want to pass the coffee asset into it. But we haven't told Hyperledger Composer what to do with those actual pieces of data. And that's where the logic comes in. The logic is where you're going to program your transactions. So inside of this logic file here, we want to use some of this metadata in the comments at the top to define exactly how this function is going to operate. What it's telling me right now is that this is going to operate for a transaction called change asset value. That was the original pseudocode that they gave us inside of this file. And let's open up both of them at the same time. So that was the original pseudocode that they gave us for the transaction down here. But we now, all we want to do is write a function for trade. So I'm going to go ahead and rename what the transaction we're interacting with is. So I'll change these to trade. And now this is telling the Hyperledger fabric that this is the function that's going to handle this trade transaction by labeling it here on the actual network namespace. And what we want to do is we want to pass in this value as trade. And so this is basically giving the no. So what this is doing, this trade here, lowercase, is saying pass in this data from the transaction as an object with the alias of lowercase trade. So that's what this is doing. And so you can see that we're passing in this lowercase trade value here into the function, into this handler function. And we're able to dive into that object. Is everybody here familiar with JavaScript and convention? Okay. So we can dive into that object and get the actual data. Do you have a question?
Yeah, so the type is any, is this TypeScript or
No.
JavaScript or?
So I have some plugins installed in VS Code for TypeScript because I use TypeScript at work. So that's why it's telling me that the type is any. But typically
so you could
this.
code though in TypeScript or JavaScript.
Yeah, there's no reason.
Hyperledger.
Yeah, there's no reason that you couldn't do this in TypeScript. Unfortunately, the code that they output for you is actually ES5 code. I haven't had to write in strict ES5 in a while. You can see that we're using strict at the top here, which is reminiscent of ES5. They also set up some ESLint styling for you. So if you don't like this, like I don't like 4-space indents, so I'll get rid of that. And so I moved that down to 2-space. So you can really set it up and customize it however you like as a JavaScript developer, and even use TypeScript if you wanted to for this. It doesn't come out of the box with TypeScript, but I would imagine IBM's push towards TypeScript might eventually lead this to use TypeScript because Loopback now, their new version of Loopback is using TypeScript under the hood, and they give you TypeScript by default. So I would not be surprised to see Hyperledger doing that with this Composer tool in the future. So what do we want to do in here? Does anybody have like an idea of what we can do with these assets? Like what is our transaction going to do on the blockchain?
Change the coffee owner to the new owner, I think.
Yeah,
For a
exactly.
given value,
What's that?
for a given value of like the transaction, right? Like I'll give you coffee, but I expect
Yeah.
Bitcoin in return.
That would be like the actual, like if you're really building this out and you wanted to show like real transactions and do this for like a real production enterprise, you might have that on the blockchain. We're just trying to simplify stuff here. So essentially, all we're doing is showing that the new owner is now the owner of a specific coffee asset. And so what we're going to do is we're going to take a coffee asset and set a new owner to it that we see down here. And
So
we're going to do, go ahead.
If we were doing what Russell's suggesting, would it go in trade, or would you have to create a new, like, I don't know, payment or something like that?
Yeah, you'd probably have to add quite a few different items to your objects in here, I would imagine. Actually, maybe not. You could probably just add it in a transaction if you didn't want to show like how much people have or anything like that. You could probably just add it in the transaction and it gets recorded to the blockchain in the amount. And that brings up a good point with Fabric, and we're not going to go into it because it's much more complicated. You can create things called channels, and you can set up a channel for specific constituents of that blockchain to only see specific data. So each channel can use data that those constituents want to see. You can also set up permissions with your certificate authority to make sure that certain constituents that are using the blockchain don't have write access to certain parts of the blockchain, don't have read access to certain parts of the blockchain. But there's a lot of cases where when there's an exchange of money or value that, you know, certain people should not be able to see those certain parts of the blockchain. And that's the beauty of these permission blockchains, is that you can set up permissions around that sort of stuff with channels. In this case, everything is open. We're just going to do like the bare minimum right here. So what we're going to do is take in the trade. Let's just, I'm going to erase all this.
Makes it work faster.
Yeah. Be easier to understand. Less noise around it. So we're gonna, what we want to do is we want to modify the coffee owner of this specific asset of coffee. So we're gonna get the trade, and we have the coffee owner on that trade. And what we want to do is we want to change that to the new owner. I know we're mutating state, and that's probably not the best practice for a lot of different paradigms, but while we're using this Hyperledger Composer, it seems to be the norm from what I've seen people doing while they're coding.
Specific for Hyperledger or in general?
If you want to do like more functional type programming and make sure functions are immutable and stuff like
what
that.
I mean in general was like regarding blockchain.
I mean, you can mutate state in JavaScript really easily, and a lot of people do it all the time. It's just like if you're creating immutable functions and trying to follow more of like a functional paradigm, which I feel like it's a trend in JavaScript these days. A lot of times they won't mutate state, and they'll create a do object instead. But there's no downside to doing that here, so we'll just do it. We're taking the coffee that's coming in the trade, and we are setting the owner to the new owner. And what we want to do is we want to propagate that new transaction to the blockchain with that new information. So I see here that I never changed this to trade. Or sorry, this should be
Coffee, right?
coffee, yes. So we're getting the asset registry of coffee, and we want to change the asset in that registry with this transaction. And so we'll put a function in here, and getting the registry will just give us a argument that we're able to use inside of this function. And once again, not using ES6, but it's okay. We'll deal with it. So we'll take the coffee registry, and we want to call update on it. So there's several CRUD methods that you can call on the registry. Updates one of those. And what we're going to do is we're going to pass in this trade.coffee that has a new owner set on it. And so what we're doing is the blockchain is recording this transaction, and now when we get that state in a UI, we're able to see that a certain amount, that the owner of that coffee actually belongs to the correct person due to this transaction that will occur. So this is just basically like another endpoint that's out there for us to hit from the UI, in addition to the Swagger setup that we're going to have. And that's it for the coding that we're going to do. Let's try deploying this. So we got to run through quite a few additional steps here, and I will show you what they are. So we're going to run composer archive create, and what this is going to do is basically create a compiled file that we're going to deploy to Hyperledger Fabric that contains all the code that we just wrote, including the models and the actual methods that we put in there. So if I check out what's in here in this directory now, you can see that it created this origin-coffee at 001 BNA. This is kind of nice because if you have multiple people running nodes, multiple constituents working on this or inside of your blockchain, you can version control this application and send out new versions via NPM with new compiled BNA files, and they can pull them down and run the new software on their node wherever they are. Next step up here is to install the Composer runtime. So you're going to use this peer admin card, which gives you admin privileges basically over the entire blockchain for anybody using the blockchain. And we're doing that so we can interact with it with no problem right now. Yeah, and if there's one part of this that was not so friendly, it was running through all of these steps. There's quite a few. I'll go back to it. So. Yeah, sorry. I'm going to leave this up though for now because people are looking at it. Sorry, I'm going to jump back over to the slide here. It's, I don't think I can I zoom on this? Oh, there we go. And then we need to import that new card that we just created. Oh, I should do it from here. Well, that's not good. Oh, it already exists. I already created this, so it should work for you. And then just for good faith, we're going to try pinging that card to make sure this all worked.
What is a network card?
So I believe that network card, that card itself is something that we're deploying as a user of the blockchain, and they have a certain certificate from an authority. So we're setting them up right now with admin privileges, and once we start interacting with the blockchain, we're going to be interacting with it through that specific user. So we have admin privileges to interact with that blockchain. So if everything went well, you should see this command succeeded. Anybody need more time or need help? No? Question? You want me to zoom in? The last one's not as important, but it's just to make sure that the network's up and running correctly. Oh, it's because you probably can't see behind you. And then the last step here is to run our REST server. And so what this is doing is taking all of our code that's been deployed and is creating a loopback server behind the scenes with RESTful verbs on each one of the members or models that we created. So you'll have the farmer, the vendor, the coffee, and the trade endpoints, and you'll be able to interact with them through this RESTful API, which is the Node SDK that we were talking about before. In order to start it up, you have to give it a name. So I believe what we have to put in here is the same name that we gave the previous card. So the admin at Origin Coffee. And I'm going to say never use namespaces. We don't have multiple blockchains running on this fabric right now, so we only have one namespace. We don't need this. You can plug in any sort of passport strategy. Is anybody here familiar with Passport.js? Yeah, so for Node, it basically gives you multiple authentication strategies that you can plug in. We're not going to do any sort of authentication, so we'll say no. I'll say yes to WebSockets, even though we're not going to use them. No to TLS, and this should start up our localhost API through Loopback. So I probably have to zoom in a lot. No, I'm already zoomed in. Cool. If it all worked, you should be able to go to localhost 3000, and it will take you to the Loopback Explorer, which is essentially just a Swagger page here, if you guys have used Swagger before for defining APIs. And it gives us a list of all of the different participants, assets, and transactions inside of our blockchain. So now we can interact with all of those in a RESTful way. Now we could create a UI that interacts with these endpoints and does any sort of thing. So if you can imagine up an application that you can build with this, when I was thinking through this, I was thinking, okay, a co-op in Guatemala, Honduras, Colombia could have an application running on one of their nodes or for one of their nodes or whatever. And so they're running an application there, a UI, and whenever a farmer comes in and they certify it's organic and they get the farmer's information, they can sign that transaction to the blockchain. They can add a new batch of coffee into this blockchain. Then once that gets shipped and a vendor actually buys it in the US, that vendor also has a UI where they can say, hey, I just bought this specific coffee and I just scanned it because it has a tamper-proof ID on it. Like, that would be kind of a solution to make sure that coffee can't be tampered with. And it is with this ID, and I'm going to transfer this now to my possession. And then you could imagine that a customer inside of a store that goes to buy this coffee has some sort of iOS or Android application that interacts with the same API, maybe doesn't have write privileges to the blockchain, but they could scan that coffee in the store and see who the actual farmer was that had grown that crop, what day he actually harvested that crop, and they can be assured that it was actually organic coffee because there was a tamper-proof label or ID that was set on that bag as it was sent through the supply chain. And that's kind of the beauty of using these permission blockchains. Of course, there's going to be a lot of challenges in between there. I'm sure you could probably pick apart some of those things I just said and say, well, what if this happens or that happens? And you probably have to work through a lot of that if you're going to build one of these permission blockchains. But let's start out by adding some items to this or assets to this. I think first we'll start out with like a farmer. So I will post a farmer. If you click on the example of data over here, it will fill it in for you so you don't have to write out all the JSON. His name will be David Zuluaga, and he'll be from Colombia, from the Medellin region. And I'll just, out of simplicity, I'll make his owner ID David for right now. And I'll try this out. I'm posting. So if we set everything up correctly, we should now have a 200 response. Yep. Yep. So now he is on the blockchain as a farmer. David is now on a blockchain as a farmer.
Permanently and immutably.
Forever.
Now an opening for a back-end.
You can also use bitcoins for coffee.
And I'm going to put a vendor. I want to add a vendor here too. And we will go with Denver Coffee. I don't know. And the owner ID, we'll just put Denver Coffee. And I will add this owner. And let's see here. I believe we might need to come back to this, but I believe that's all we need. Did anybody? Yeah, eventually we'll get to that. Did everybody who's following along clone down the repo of the front end? Yeah. Okay. So if you can go in there and run npm install, that will get you set up on the front end. Apparently these are separate. I'm going to cd into that directory right now. And I'm going to, I already installed it, so I'm just going to run npm start. And what this is, essentially, it's the Angular application that the Hyperledger composer Yeoman generator lets you choose. So if I were to go into here and create a new project, like we saw before, you can choose a network or you can choose an Angular application. We chose a network just to build the actual blockchain. If I were to choose Angular, it's going to generate this Angular application that has all of the AJAX set up to communicate with that RESTful API that we already have automatically. It's kind of ugly. I'm more of a front-end developer, so looking at that code was a little disappointing. You got a question?
Yeah, I do. So for the front end, do you have to have Angular installed?
You don't have to install Angular because it is included in the npm packages that install as part of that project.
Got it.
Yeah.
What version of Angular?
I think it gives you probably one of the newer versions. It was definitely after Angular 2.0. I don't know.
JS.
Yeah, it was Angular. Or is it
Yeah,
Angular?
the JS. Angular's the old JS. Is the
Okay,
new
I thought it was the other way around.
It's the other way around.
Yeah,
Oh,
I think Angular is
4+.
Angular's the new Angular JS is 1x. So it's part of Angular. I'm not sure the exact version. We could check it out inside of the project.
So ended up being an Angular meetup.
Yeah, in the end, we took it full circle. We got it exactly where you wanted it to be. So I believe that's running on localhost 4200. And you should see here, what I did is I built in on the dashboard all of the transactions that are going on the blockchain. So you can see that participants were added. There was some other stuff going on with starting the business network and everything. Basically, I wanted to generate this and have this here for people following along because it would have been a lot of work and unnecessary work for us to run through front-end development and set up applications on the fly here. It's really a crude example of what you can do with this. But I wanted to say like, hey, here's all the transactions when we get to the page. But if we had separate applications, like you wouldn't do this all in one application. You could have an application for vendors and you could have an application for cooperatives. So for example, if we go to a cooperative, they would have the ability to add a new asset to the blockchain. And like I said, it generates some nasty code, so you get stuff like this in there. Like not everything is going to look perfect. But if you're a front-end developer, you should be able to go through and figure that stuff out and set it up right. So from this interface here, we can add coffee. And that's the goal of this cooperative. We're saying it's a Colombian farm cooperative, so our farmer, David Zuluaga, is going to show up one day with all of his crop, and he's going to say, hey, I have all of this organic coffee. Here's all the sacks, 20 sacks of organic coffee. I want to sell them to you, and they can add these assets to the blockchain at this point. They could go through, run all of their tests and whatever experiments they do to figure out and verify that it's actually organic coffee at that point. And they can add an asset to the blockchain that is organic and with all of David's, or knowing that it's from David. So once again, coffee ID. I'm just going to put anything in there right now. You probably want to do better than that if you're actually building the blockchain. Pounds, we'll say 2.2 pounds is the sack of coffee that he's arrived with. We'll say arrived with 1 sack instead of 20 for simplicity. And it's organic. And we will say that the variety is Katwai. And the owner is, I think we use the ID of, oh, this part's a little more complicated. Let me go back here. Where's our... Yeah, I think we can use David here. Yeah, so we'll try that out, see if that works. So because I did not set up any sort of callback that's going to reload the page, it didn't do anything. But as soon as I reload here, we can see that was successful. This coffee ID, pounds, organic, harvested at, were all added to the blockchain. So now his asset is now recorded on the blockchain, and this cooperative sends it out to the US to a Denver coffee vendor, and they can see all of the assets that are still on the blockchain. So we can see here that this asset exists, and it just arrived, and so we want to transfer the ownership to ourselves before we give it out to the customer. So we can click this transfer ownership, and I'm going to use this kind of ugly namespacing here. This is the proper way to enter in the data of the owner. You can get away with just entering the ID, but because of reasons I'll kind of leave out here, because we're using a shared owner abstract in here, I have to refer to the person directly. And does anybody remember what we call the
Denver coffee, all lowercase.
Denver coffee? Yeah.
Is there a reason that looks so much like the Java name spacing?
I honestly do not know. It just seems like whoever was working on it was probably from the Java world, but
That's all right, yeah.
yeah, there's probably some more specific reasoning behind it. So we transfer ownership, and you can see now that the owner of this is Denver Coffee. And if we go home, these aren't ordered correctly. I should have set them up to order by timestamp. But at some point in here, you should see that that trade actually occurred on the blockchain. So now we have this immutable record of everything that that coffee has done on the blockchain. And you can imagine what sort of applications you could deliver to a customer that wants to be guaranteed of certain things when they go to buy that coffee. Any questions? This is pretty much, I'm gonna wrap it up from here, I think, unless you guys have any questions about this.
So then, John, once that coffee is purchased and, purchased by some customer and consumed and it's gone.
Yep.
Can you ever delete things off the blockchain, or are they just there in perpetuity?
So all of the transactions will always be there, but if you have an asset such as coffee, you could say that that coffee, I mean, if you're using weights, you could make a transaction that says the coffee is down to 0. There's probably very specific ways which you could handle that by setting a flag, maybe, saying that that's been sold and that no longer exists.
Like a new object, so your last time to go to nil, no more transactions in the real world would happen because there's nothing to be sold. And now you're not selling coffee 1, 2, 3, 4, you're selling coffee 1, 4, 5, and your point of sale would handle that difference, right?
I'm not sure I followed.
So you can't delete it, but it's no longer for sale. So you
Yeah.
can effectively remove it and effectively put a new product in its place, right? But the purpose of any ledger is that it's a ledger, it exists, right? There's no transaction
Yeah.
history, coffee 1, 2, 4.
The
no
way-
longer on the market.
When you mention that, I start thinking about cryptocurrency, and like when you transfer cryptocurrency, you don't actually delete like the currency. Like when I send you cryptocurrency, I'm not deleting the currency that I have. All I'm doing is putting a transaction on the blockchain that says that I no longer have that currency, that you now have that currency. So
Sorry.
yeah, no, you.
So I guess my question was sort of alluding to a larger question that as things continue to be added to the blockchain gets bigger
Yes.
and bigger. Are there
Yep.
performance implications of that?
I believe so. If you're using a permissioned blockchain and you have extremely high throughput, I'd imagine like maybe a financial company where you're recording every single investment that goes through your back office or something like that. You could end up with a very large blockchain where it might be several gigabytes or more. And I'd imagine at some point the hardware would need to be specialized to be able to handle that. I feel like there's very few use cases where that sort of throughput is going to exist in a permissioned blockchain. Like right now with Ethereum, I can download the Ethereum blockchain on my computer, and this is a global cryptocurrency with like millions and millions of transactions on it. But it's growing every day, and that is a valid concern of people as it grows, because you do not want to get rid of that old data that's on there, or you cannot get rid of it. I'm sure there's probably I'd have to get back to you on this. I'm sure in a permissioned environment, there's some way, because you're all trusted, to be able to say, hey, let's all drop this data from our blockchains because we don't need it anymore. But I do not know what that would be. And that's about it. I think I had one more slide just to go over what's going on behind the scenes, but there's not too much that we didn't get to here. And yeah, we'll call it a wrap there. I can't get to the slide. But yeah, that's basically Hyperledger Composer in a nutshell. If you guys have any questions, come up and ask. I've got cards here if you want to ask me afterwards. I hope you guys check out the technology. Try it out.
Cool. Thanks, guys.
Yep.